before going, today we will study a very important topic. At least the power sector of Bangladesh has a very important aspect on this topic. This topic is basically, my student, known as gas turbine power plant. Okay, a small scale power plant. We have studied the turbine power plant. Okay, but today we will study the gas turbine power plant and also the blended strategy to make a combined cycle power plant. So I have found a video. I will also share this video link with everyone. This is basically the combined cycle is basically steam power plant and the gas turbine power plant together. Okay, together they can increase the efficiency of the overall system. So this is the new technology. It is, the steam turbine power plant has been converting to the combined cycle power plant. So first of all, we study the gas turbine power plant, then we discuss the combined cycle power plant. So before going there, this gas turbine power plant is basically, my student, uh, it's a one-sided device. You know that the steam power plant has different components. There's boiler, the turbine, the condenser, the pump, and everything, at different stages. But the interesting thing is that the gas turbine power plant requires a very less area, because all the device are together, one by one. You see that a line, this is a straight line like a conveyor belt. Every component is one by one. Okay, so that is the important thing. That's why the gas turbine power plant can be installed in a less area also. Clear? In the less area also. So that is one of the advantage. But there are some disadvantage also, the gas turbine power plant. Let me forward the conversation. Basically, you all know that the gas turbine power plant basically is use the environmental air, the normal air, environmental normal air. And the major three component of this gas turbine power plant is, one is compressor, which is basically compress the air. Another one is the combustion chamber, where the burning of the fuel happens. And another one is the gas turbine, where basically the rotational force generates, and it is coupled with the generator and then from the transformer. My student, always remember that the generation of electricity is basically done by generator. And we all know generator rotor is basically moved. Generator rotor is basically moved, and it requires a prime mover. Clear? It requires a prime mover. These are the information I'm sharing, is a practical information. This is prime mover. That requires a prime mover. It is basically connected with the rotor. We know the generator has two parts, stator and rotor. So the prime mover is basically connected with the rotor. And also remember, turbine is a prime mover because it moves the rotor. So turbine is a prime mover. So that's why you see that the turbine will be connected with the generator rotor. Interesting thing, one more thing, you see that the turbine, the generator, and the compressor, there is a common shaft, my student. You just see that that is the important thing of the gas turbine power plant. There is a common shaft. You see the compressor, the turbine, and the generator, the common shaft. That means when the turbine is moving, it will be moved with both the generator rotor and the compressor. Okay, because all three are connected together by a common shaft. Okay, so that's why, my student, the operation starts that at first the normal air from the atmosphere goes inside the compressor. The normal air, atmospheric air, goes inside the compressor. Then in the compressor, what happens? In the compressor, my student, you know that compressor basically compress the air. So definitely the pressure will be increasing. The compression means the volume will be decreasing. The volume of that air will be decreasing, but the pressure will increase. We all know that there is an inverse relation between volume and pressure. Inverse relation, বিপরীত সম্পর্ক. There is an inverse relation between pressure and volume. So that's why, my student, you know that the pressure will be increased, and we also know that the pressure and the temperature is the, you know, the proportional, directly proportional. That means if the pressure is increasing, the temperature is also increasing. So in the compressor, the atmospheric air goes inside it, and the temperature increases because of the pressure increase. So this air has been then sent to the combustion chamber. The combustion chamber is that chamber where the burning of the fuel happens. The fuel has been burned, burned and made to the, heat energy. The fuel has been burned. So, my student, here you see that there is a fuel oil storage or the natural gas line. Anything which fuel is basically available to you, you can use anything. In our country, the Bangladesh, the 63% has been, taken, the energy has been used by natural gas. Natural gas is very popular in this region because it is available. So that's why, it can be either oil storage or natural gas. It's not a big deal. So in the combustion chamber, this fuel is burned. So you know that when the fuel is burned, the heat energy is generated, and when the heat energy is generated, the temperature is also increased. The temperature is also increased. So when the heat energy is generated, the temperature is also increased. So you know that temperature and pressure is also directly proportional. So when the temperature is increased, the pressure is also increased. So after the combustion chamber, the air has been converted to hot flue gas, is high temperature and high pressurized atmospheric air. So then it has been transferred to this gas turbine. There is several stage of gas turbine which basically pushes this turbine blade, and the turbine blade basically rotates. Okay, and after that, the exhaust, from the exhaust, my student, it has been, given out. It has been given out. So this is the common strategy of gas turbine power plant. So now I will move forward. Whatever I just told, I will move forward to a video. The video, you will see that how the gas turbine is basically works. Gas turbine is basically introduced or used in the different small power plant, and also in the jet engine, in the aeroplane jet engine, where the gas turbine is also increased. So let's see the video, enjoy the video, and discuss from the video also, because it will help you. This video is basically made by a atmospheric air, and you see that how they are discussing. I will discuss, thoroughly. It's a normal air. You can see this is the normal air atom. This is the particle of the air. Okay, so this particle of the air, my student, basically what will they will do? In the aeroplane, can you see the video, or is it's not working, my student?
Sir, we see the video, but it did not work.
Is it working?
No, sir.
Okay, okay. Yeah, it's not working properly. But it should be working. Okay, let me try one more time, because Zoom it has this kind of problem. Mm. Can you see now?
Yes,
My
sir.
student?
It's okay, sir.
Okay, it's okay. Okay, now let's discuss. This is, basically the particle of the year. The particle of the year, and a aeroplane is coming where there is a gas turbine. So basically, you know that the first thing of the gas turbine is the air. The normal atmospheric air will go to the compressor. Okay, will go to the compressor. The first thing, the normal atmospheric air will go to the compressor. So you see that this is the gas turbine. In the aeroplane, there is a gas turbine available. So this is the gas turbine. So it takes the air and emits the air after the existing. So they will now, show you in the animation wise, the first step by step, that at first the normal air enters inside the gas turbine. Okay, you see that a particle is moving. So they're going inside the gas turbine, and the first stage is the compressor. The first stage is the compressor, my student. In this is the compressor stage, where the particle of the air is been, you know compressed, is been compressed. They will discuss one by one. Let's see. First of all, they're talking with each other. I will the particle of the kerosene. You see that this is the combustion chamber. When the air has been compressed inside the, compressor, then already the temperature is, increased. You see that they have entered into the blue color. Now it's a little bit reddish. That means they have gained the heat energy. And you see that the kerosene is kind of, fuel, an oil. So kerosene particle is also connected with them. You see that in the combustion chamber. Then see that what happens. The fuel has been mixed with the air. Then probably the combustion chamber. It's a very interesting animation video which will help you to understand this very well. So in the combustion chamber, you see that everything is, starting to getting red. It's starting to getting red. So you see that now it's the red color is very, very high. That means they have huge pressure and huge heat energy. Okay. So then now they are moving to the turbine. Now they are moving to the turbine stage. This high pressure and high temperature, they are moving to the turbine stage. So that is the way, just they have shown you the step as a particle way. And after that, it has been released. Okay, so in this way, now they will draw the conclusion after this video. Please, I will. So that, what did we learn from this animation video? Basically, this now the make the conclusion that the gas turbine is an internal combustion engine. That means the fuel is, burned inside the, engine. You have also saw the petrol engine, diesel engine, that is also the internal combustion engine. So they have figured it out that the gas turbine is also an internal combustion engine. It uses a combination of compressed air and fuel to produce energy. The first stage is, taking the air from the outside, make the compressed by the compressor, and mixing with the fuel, then use the high temperature and high pressurized air to the turbine. Okay, so you see that there are three things. One is compressor, then is combustion chamber, the third one is the turbine, my student. The first is the compressor. The first stage is the compressor, my student. Then the compressor, basically you see that the animation inside, that this there is the air intakes occurs in the turbine. That means the first from the outside or the atmosphere the air is taken, then it is compressed, and which increases the pressure. That increases the pressure is also increases the temperature. Then stage is the combustion chamber, my student. In the combustion chamber, you see that the burning of the fuel happens. The fuel burning, you see that the burning is happening in the animation also, where the fuel is mixed with the air, and also the combusted means the burning, the air fuel mixture is combusted, and the combustion produces energy to this material to go to the turbine. Then the turbine comes. Then the turbine comes. So the ignited air fuel mixture is then directed to the turbine section. It goes to the turbine, and there is a series of blade which is connected to the common shaft, and the turbine basically rotates. And after that, it is connected with the the shaft of the rotor, and it produces the electricity. So basically now they will show the applications. First of all, it is used for the the industrial power demands as a power plant, and also the jet applications, or aeroplanes, or even train also. So that's how, my student, um, basically I use this video, and I try to show this video just to give you the physical idea that how basically the gas turbine power plant works. Now the interesting thing is that, first of all, you see, there is a compressor available, and compressor is a device where you have to give work. It will not start automatically, you have to give the power. So that's why, my student, you see that the compressor is also moved by the turbine. But my question is, at first, at the very beginning, the compressor works at first, then the combustion chamber, then the turbine. So at the very beginning, my student, the compressor should be started by other things, because if it is not started, the air cannot go to the turbine to start the electricity production. So first of all, the the compressor should be started. So at the very beginning, a starting motor, a starting DC motor is connected with the compressor, which basically starts the compressor at the very beginning. At the very beginning, a starting motor is required for the compressor. So when the turbine is producing electricity, at that time it is moved by the turbine. The compressor is moved by the turbine at that time. But at the starting portion, there is a starting motor required for the gas turbine power plant. So that's one of the important question, that why a starting motor is required for the gas turbine. And now coming back to the one more point, that after this turbine, the gas goes outside. The gas goes outside, and there is a huge amount of heat energy available in this gas. So if I release this gas into the environment, then at that time, what happens? We are losing heat energy. We are losing our heat energy. So therefore, the idea of the combined cycle comes, where that this hot gas is then basically used to the steam power plant in the boiler, my student. So combined cycle power plant is a combination of gas turbine power plant and steam power plant. So in the gas turbine power plant, the exhaust gas has a huge amount of heat energy. And we also know that in the steam turbine power plant, we get the air from the outside to make the boiler. In the boiler, we take air from the outside. So in the gas turbine power plant, we are releasing this huge amount of gas. So in the combined cycle power plant, these gas have then transferred to the steam power plant boiler, and from there this hot gas is used to produce the steam of the steam turbine power plant. So together we are using the same fuel. So now the fuel will be less required. So the overall efficiency of the steam power plant will be increased. So that's why the gas turbine power plant and the steam turbine power plant are working together, and it is known as combined cycle power plant. Probably in your final exam I can give you an assignment on combined cycle power plant. You can start working from now on also, but the assignment will be on combined cycle power plant. Okay, let's see the video to get a little bit more idea. I'm directly showing from the YouTube, my student. So you might get a little bit low quality. Uh, but I will give you the link that how a combined cycle power plant basically works. It's a 360-degree video, my student. You can use your mouse to show the 360 view. So basically in this video they are showing that the how the combined cycle power plant basically situated. There are two parts. One is steam power plant, another one is what can I say, one is steam power plant, another one is the gas turbine power plant. It's together. So basically gas turbine is the where the fuel is burned to spin the generator. Okay, so from the gas turbine, my student, from the gas turbine we all know that the fuel has been burned to spin the generator, but after the gas turbine there's a huge amount of heat energy that is required. So then it is transferred. This heat energy is then transferred to the steam power plant. This is heat recovery steam generation system. It is captures the exhaust heat from the gas turbine and creates steam. That means the exhaust of the gas turbine power plant, the exhaust gas that is transferred to the steam power plant, and it is basically used for the steam generation of the boiler. See the main steam piping. So this video is I will give you the video link, so you can at that time you can see this much more in a better way, but this is having some trouble in loading. But the main interesting thing is that I'm again to tell you that the gas turbine power plant, the exhaust gas has a huge temperature. So this exhaust gas has been converted to the or transferred to the steam power plant, and then steam power plant receives those heat energy and makes the steam. So basically we, instead of releasing this heat to the environment, we are using this heat in the steam power plant. Okay, interesting thing is that my student, that in the major part of the power developed by the turbine is consumed for driving the compressor. You know that the compressor is also driven by the turbine. The compressor is also driven by the turbine. So that's why a certain amount of major power is developed by the turbine is used to drive the compressor. So efficiency of the gas turbine is a little bit lower side for this region. For this reason, that because we have to drive the compressor also by the power developed. So that's why it is the major part has been used to drive the compression. This is the schematic diagram, my student. You can see this is the compressor, this is the turbine, and this is the combustion chamber, and finally if we release the heat into the uh, atmosphere. So this is the uh, schematic diagram. You see the common shaft, because the compressor and the turbine are in the common shaft, and we know that the net work is turbine work generated minus the compressor work, because the compressor work we are providing from the turbine. That's why the net work will be the turbine work minus the compressor work. Okay. So the PV diagram and TS diagram is the same, just like in the steam turbine, steam power plant, or even in the Otto cycle power plant. In the IC engine, it is the same thing. If you just go for the same logic, the diagram will be exact same. And the gas turbine cycle are known as Breton cycle. The Breton cycle is known in the gas turbine power plant, but in the steam power plant it is known as Rankine cycle. The petrol engine is known as Otto cycle, and the gas turbine cycle is known as Breton cycle. Okay, one more thing is that if I use the gas turbine only, this exhaust gas, we used one more chamber that is known as regenerator. That is known as regenerator. So the exhaust gas is passed with this chamber regenerator, then go to the chimney, and after the compressor, the the air is then transferred to the combustion chamber. So in these two gas, when they are passing from with the same chamber, we know that the exhaust gas is having a higher temperature. So when this is the higher temperature, the heat will be the heat, you see that the heat will be going to the incoming air. So that means they are absorbing much more heat. So that means we are recovering the heat from the system. Instead of giving out to the atmosphere, we are taking those heat inside the system, because when the two air is passing between them, at that time, my student, the higher air will give the heat to the lower air. So that's why the overall efficiency can be increased by using the regenerator. It's a chamber just like economizer. Remember economizer in the steam power plant, that it is just like the heat recovery system, that instead when we transfer the exhaust gas to the environment, at that time, my student, it is just passed with the regenerator, and this regenerator basically increases the overall efficiency. Okay, so that is one of the also important part. If the gas turbine is worked only alone, these are the important the compressor. What is compressor is all about: the regeneration, the combustion chamber, the gas turbine, okay, and starting motor. Because before starting the turbine, the compressor should be started first. So for this purpose, the electrical motor is mounted in the turbine, so the motor is energized, and a mechanical power is developed so that the compressor can work. But when the turbine is at rated speed, then the starting motor is cut off. So I think that you have understood the gas turbine power plant, and also the concept of the steam combined cycle power plant. So the thing is that you have an assignment. You start from now on, work on now on the assignment. Your one assignment will be on the combined cycle power plant. The main thing is that it is basically combined with gas turbine power plant and steam turbine power plant. So is there any question from my students about this gas turbine power plant? I will be happy to answer.
Yes, sir.
Yes, please.
Yes, sir. I have a question, sir. For the first beginning, sir, we have DC starting motor, right? For the
Sorry.
compression. So, yes, sir.
Yeah.
Compression, sir.
Yes,
Compression, when
compression.
we needed to start, we need, sir, DC motor, right?
Yeah, yeah. DC motor, any kind of motor, electric motor, that is, basically DC motor is used. Yes.
Yes, sir. Sir, where we can connect it, sir? How we can connect?
Basically, you think that here in the diagram probably it is not shown. Okay, basically a DC motor, a backup motor is connected with the shaft, but because when this turbine is not getting forced by the yar, at that time suppose a DC motor is connected here, so it is when this is motor is run, this shaft is also moving, this shaft is also moving. So at that time, my student, this compressor is working, because when the compressor is working, after that the air will go to the turbine, and the turbine, it is not at the very beginning it goes to the rated speed, so slowly it goes to the rated speed. So when the turbine is goes to the rated speed, then the starting motor is cut off. In this diagram, the starting motor is not shown because this is just the generalized layout, but the DC motor is basically connected with the shaft, so that in the last line you can see there is a written that before the starting of the turbine, the compressor should be started at first. So for this purpose, an electric motor is mounted on the same shaft. That means the same shaft, because the motor has also a rotor, so that rotor is also connected with the same shaft of the turbine. So the motor is energized by the battery. That means the battery is definitely the DC motor, you know so when the motor is energized, once the unit starts and a part of mechanical power of the turbine drives the compressor, there is no need of the motor then. That means when the turbine is producing the power, at that time the starting motor is not required. Clear?
Yes, sir. Clear, sir. Thank you.
Okay. Is there any question from my other students? My dear student, you can ask. Okay, if you do not have any question, then I will say that study very well. Okay, whatever the topics I have shown you, study very well, and also prepare for the exam. And one more class, that is psychometry. I will give you the recorded video of that class. Please see this video very carefully, those video. Okay, and because I have taken that class, so it's not that that will be also the class. You will see the video just like a class and study properly. The materials I will give you everything in the Google Classroom, so you use those video and use those lectures, everything from the classroom, and study properly. And also pray for me for my job, that I can stay well, and if I come back to the university again, it will be also a very happy meeting you. I will try to come to the university after the COVID period, sometimes for the visiting purpose also. So pray for me. That's it. Okay, and study the lectures very well. Clear? And please, if the other students are not known, please inform every students. Okay.
Okay, sir. I will inform all of them, sir.
Okay, thank you
Sir,
so much.
in the assignment, sir, do we submit for the Google Classroom or submit in other way?
The assignment,
Yes, sir.
I will instruct, no problem. You don't need to worry about it. I will instruct.
হ্যালো
Okay,
স্যার।
sir.
Yes.
স্যার এটা তো স্যার শেষ শেষ ক্লাস।
হ্যাঁ,
স্যার ওই অ্যাসাইনমেন্টটা স্যার গুগল ক্লাসরুমে স্যার দিয়ে দিতে হবে স্যার, নাকি স্যার ডেট?
আমি জানাই দিব, তোমাদের পরীক্ষা শুরু হোক আমি জানাই দিব, সমস্যা নেই। I will
আচ্ছা
inform
ঠিক আছে।
the when to submit the assignment, where to submit the assignment, is it mail or Google Classroom. I will inform everything. You don't need to worry about that. Okay, you just prepare your assignment. Assignment topic is combined cycle power plant. Clear?
ওকে স্যার, আমাদের জন্য স্যার দোয়া করেন স্যার।
Okay, ভালো থাকো everyone. Okay, have a best career
আল্লাহ হাফেজ স্যার।
ahead, and see you soon, and be connected into the messenger. I will be connected into the messenger. Okay, if you have any problem, contact me into the messenger group.